problem Pencast 10. We start problem 4.10. We are given a sphere, radius r, big R. It has a polarization inside the sphere in the r hat direction, that is kr or k in the r hat. Okay. So part A says to find the bound charges. Sigma b is p dotted with n hat. Both p and n hat are in the r hat direction, so it's just the same as the polarization, which is kr. Okay, and then row bound is the negative del dotted with the polarization. Since we only have the r part, we just get the 1 over r squared, partial of r squared, dotted with polarization, which is kr. And after going through and doing that math, we get that this is negative 3k. Then part B asks us to find the field inside and outside the sphere. So we're going to start by the integral of d dot dA, which is equal to q free enclosed. There's no free charge given on this problem, so that's just 0. And then by symmetry, we have d integral of dA equals 0, or d equals 0. And since d equals epsilon naught e plus p, we can just say 0 equals epsilon naught e plus p. So then starting inside, we have 0 equals epsilon naught plus e plus the polarization, which inside is kr in the r hat. So epsilon naught e equals negative kr in the r hat, and then e equals negative kr over epsilon naught in the r hat direction. Outside, we need to find the two different electric fields, one from the bound charge, sigma bound charge. So the integral of E dot dA gives us E times the integral of dA, which is just going to be 4 pi r squared. And then we have Q over epsilon naught, which is sigma r squared over epsilon naught. Right? No, sigma times 4 pi r squared epsilon naught, or epsilon naught. And then doing some rearranging, 4 pi's cancel, and then E sigma equals, what am I doing? Oh, because sigma is kr, we put an r there, and we get k r cubed over epsilon naught r squared in the r hat direction. And then with the bound charge, the volume bound charge, once again we have the integral of E dot dA equals E times 4 pi r squared. And then we have rho times the volume, which is 4/3 pi r cubed over epsilon naught. And E equals rho r cubed over 3 epsilon naught r squared. Plugging in for rho from up here to the negative 3k, we get that this is negative kr cubed over epsilon naught r squared in the r hat direction. And then total E is just the sum of these two. And if you notice, these are the exact same expressions, just one the positive of the other. So total E is just 0 outside. Part C. Now we have the almost near same problem, except P is now AR squared in the R hat direction. So sigma B, once again, they're in the same direction, so we get this same from the same logic. Sigma B is the same as the polarization. And then rho b is negative 1 over r squared, partial with respect to r squared times ar squared, which gives us negative 4ar. So then we now need to find the new field inside and out. So all the logic stays the same, except now we just have a different polarization, but everything else stays the same. So for inside, using the same logic that 0 equals epsilon naught e plus ar squared in the r hat direction, we get that e is just equal to negative ar squared over epsilon naught in the r hat. And then for outside, we go through the same logic for the sigma bound. So I'm just gonna skip to the part where we put in the sigma value, and we end up getting negative ar squared, negative 4a big R to the fourth over 3 epsilon naught little r squared for sigma. And then for rho, once again going through the same logic, just now putting in a different rho value, this one right here, we get negative 4a r to the fourth over 3 epsilon naught r squared in the r hat direction. And then e is the sum of those two, so summing these together